Okay, we are in 2.5. We are going to start talking about proofs today. And like we learned today in class, proofs are like peanut butter and jelly sandwiches. We do proofs so much in math. They're really important. They're directions pretty much. And I'm going to tell you, always give you some information, like a picture of a triangle or something. And then I'm telling you what the ending is. So what you have to do is you have to go ahead and tell me the story or tell me the directions of how we go from this given to the proof. So, for instance, in class we did the given two slices of bread, a knife, jelly, and peanut butter jelly, or peanut butter. You're going to have to prove how to make a peanut butter and jelly sandwich. And so a two-column proof is what we're going to be doing in this class. And on the left-hand side is where you do your math, and on the right-hand side is where you write your reasons. So today we're going to start talking about how to make a two-column proof. And some vocabulary you need to know is that, yes, proofs are like directions, or a story, if you will. There's different properties that you're going to use on the right-hand side of your column, different reasons, if you will. Properties of equality and properties of congruence. And I'm going to shortcut these to my pose and my pox. So pose stands for property of equality, pox stands for property of congruence. Now remember, equality, there's an equal sign. And so when we're talking about properties of equality, we're talking about numbers. For example, anytime you want to multiply, add, subtract, divide, you're talking about numbers, and so you're going to be using pose. Pox use congruent signs, and so we're not talking about numbers, we're talking about things. We're talking about angles, we're talking about segments. Okay. There are three things in pose and pox that you're going to have to talk about, and we're going to come back to that at the end of the video. So really quickly, I want to start you off, and I want to introduce proofs to you with something you already know how to do. You already know how, you guys already passed algebra, sorry, and you already know how to solve these equations. So let's start off with this first problem. 4m minus 8 equals negative 12. We're starting with this equation. That's what they give us. So we always start our proof off with the given. This should always be your first step. And then in this case, we want to solve for m, but I don't really know what the reason is yet. So we're going to go from point A all the way to point E, and we're just going to do our algebra. So let's see. If you wanted to do the algebra, the first thing I want to do is I want to add 8 to each side. Now, do you have to add 8 to each side? No, you don't, but that's what I want to do. And just like in the peanut butter and jelly directions, there's different ways you guys can write these stories. Since I'm adding an 8 to both sides, that's called addition po. I'm adding numbers to both sides. And now I'm going to simplify. So 4m equals, and let's see, negative 12 plus 8, that's negative 4. See how I actually did some math here? That's called simplify. Okay, and then the next thing I'm going to do is divide both sides by 4. Since I'm dividing both sides by 4, I'm doing something to both sides. That's called division po. And now I'm actually going to do my math. Negative 4 divided by 4, that's negative 1. Since I was doing math, that's called simplify. So the difference between simplify and addition, multiplication, division po is if you're actually doing something to both sides, that's a po. Like I added 8 to both sides, that's addition po. Since I was just dividing 4 over here, that's called simplify. Okay, so I want to see if you guys can do number 2 in your notes. Again, there's different ways you can do this. You can have more than 3 steps if you really want to. And that's just this. So this is an introduction into proofs. Okay, let's take what we did in chapter 1, and let's throw proofs in there. So I want you to write a justification for each step, and all I want you to do is solve for x. Okay, so here's number 5. We have this picture. So I'm just going to write picture, and that's my given, right? Sometimes you can do that. Okay, now I know that this segment, this baby segment, plus this baby segment is going to equal the whole mama segment. Now let's see. So I'm going to say NM plus MO equals NO. And what is that called? What was that called in chapter 1? That was called segment addition postulate. So in the beginning of this, we're going to be using two things, segment addition postulate, or you're going to be using angle addition postulate. Okay, so now I know that this segment plus this segment equals the whole big mama segment. Now I'm going to plug in. So let's see, NM is 2x. MO is 3x minus 9. And the whole big thing is 4x minus 4. And what did I do? I just plugged in, right? That's called substitution. I was substituting in those variables. Now I want to see if you can finish the rest of this proof. Title this number, you can title this number 5 or number 3 if you're in HP. And you could have more steps if you totally need to. That's fine. The very last thing I want to talk about are 3 properties. Actually, we'll talk about those 3 properties tomorrow in class. All right, so last you're going to do is finish number 5, and you're going to finish number 2, and we'll do the rest in class. So yay, we're starting proofs.